This is a mass M, and it is this spring gauge attached at the ceiling, and this is mass M, which is attached to this spring. This was the normal length of the spring. This one, due to the load of this mass M, it there is an extension of x here. So my first equation will be mg equal to kx. This is my first equation. Now there is another mass small m, and it is at a height h above the m. So when it reaches here, it hits this capital M and sticks to it. So like when it reaches here, the speed attained by it is underscore 2gh. So, and once it hits this mass m, both m and m, small m sticks to this mass m, so both will attain a velocity v. So my equation for linear momentum will be m root 2gh is equal to m plus m v1. V. This is my second equation. Now when this both mass m plus m attains some velocity, there is an other extension here, that is of x1, and once it reaches here, this mass comes to rest. So suppose this is the level, this is my basin. So initial energy, what was the initial energy? So this height was initial energy for mass m was so initial energy for mass m was first of spring was half kx square plus the initial energy for mass m was this m plus m g, and this height is x1. I am considering this line, means I am calculating all the potential energy from this line. So this is x1. What was the kinetic energy here? Half m plus m v square. Now when it reaches here, what would be the energy? Only energy stored in a spring will be there. So half k, and this was x was the initial extension. No, there should be, yeah. So half k x1 plus x square. So this is my third equation. So first equation was mg equal to kx, that was in the initial stage. That this is a linear momentum equation, that is mv is equal to m plus mv, and the energy equation is initial energy was half kx square, because this was the initial extension in spring, and there was m plus mg x1, because this height is x1, plus half m plus m v square. That will be the final energy will be half k x1 plus x whole square, because this is x1 and this total is x, so total extension will be x1 plus x. So these are the three equations which will be helpful to us in this situation.